So, given our sketch, we have the barrier of 24 volts and 7 resistance. Resistance 1, 10 ohms. Resistance 2, 2 ohms. Resistance 3, 6 ohms. Resistance 4, 4 ohms. Resistance 5, 12 ohms. Resistance 6, 10 ohms. And resistance 7, 5 ohms. So, we analyze the sketch and we conclude that we can eliminate resistance to make it easier. So, first we can eliminate the resistance 3 with resistance 4. And for this we use the formula to resistance in parallel. That is 1 over resistance 1 plus 1 over resistance 2. So, we substitute and we get 1 over 6 ohms plus 1 over 4 ohms. And then we get 2.4 ohms. Then that we have one resistance we can eliminate with the resistance 2, but in this case it's a circuit in parallel, so we use another formula that is resistance 1 plus resistance 2. So we substitute, we get 2 ohms plus 2.4 ohms, and as a result 4.4 ohms. Then that we have this resistance we can eliminate with the resistance 5. So we use the first formula that was for resistance in parallel, 1 over resistance 1 plus 1 over resistance 2. So we substitute 1 over 4.4 ohms plus 1 over 12 ohms, and then we get 3.22 ohms. Then that we have our resistance, we can eliminate the resistance 6 with the resistance 7.
That phase though.
Using the first formula for resistance in parallel, we substitute, then we get 1 over 10 ohms plus 1 over 5 ohms, and then we get 3.33 periodic ohms. So
then we have the resistance 1 and the another resistance in parallel, but in this case we have a circuit in series. So we use the second formula, that is resistance 1 plus resistance 2 plus resistance 3. And then as a result, we get 16.55 ohms.
Our equivalent resistance is equal to 16.55 ohms, and our voltage is 24 volts. To obtain our current, we have to disbehave the formula, as you can see, and we obtain that the current is equal to 1.45 amperes. So, as it is a circuit in series, we have that the current is the same for each one. So here I'm writing it and obtaining the values for the voltage using the formula. As we are using the Nacho method, we're going backwards. So what I'm doing here is obtaining the values we don't have. So as it is a parallel circuit, we have that the voltage values are the same. So it is 4.8285 volts, and using the formula we can get the current for each one, and there are.
then we do another parallel circuit, and we also have that the current values are the same. So the value for that is 4.669 volts, and also we're obtaining the
current values for each one using the formula.
Now we have a series circuit, so we have that our currents are both the same. Our current is 1.0611 amperes, and we obtain the value for voltage with the formula.
Finally, we have our last parallel circuit, so it means that our value for voltage will be the same, which is 2.54664 volts. Then we substitute in the formula to obtain the currents for each one, and we're done.
How does a microwave work? Inside the strong metal box, there is a microwave generator called magnetron. When you start cooking, the magnetron takes electricity from the power outlet and converts it into a high-power radio waves. The magnetron blasts these waves into the food compartment through a channel called a waveguide. The food sits on a turntable, spinning slowly around so the microwave cooks it evenly. The microwaves bounce back and forth off the reflecting metal walls of the food compartment, just like bounces off a mirror. When the microwaves reach the food itself, they don't simply bounce off. Just as radio waves can pass straight through the walls of your house, some microwaves penetrate inside the food. As they travel through it, they make the molecules inside it vibrate more quickly. Vibrating molecules have heat, so the faster the molecules vibrate, the harder the food becomes. Thus, the microwaves pass their energy onto the molecules in the food, rapidly heating up.